Welcome to Genique. In the last class, we have seen the 4 results, very important results. Those 4 results are closed surface integral d dot ds is equals to q, okay, and del dot d is equals to rho v, and second one is closed line integral h dot dl is equals to I, and one more result, del cross h is equals to j. These are the 4 very important results we observed here. Okay, so these 2 are called as the Gauss laws. Okay, the first one is Gauss law in point form, and the second one is Gauss law in Gauss law in the integral form, and the second one is the Gauss law in the point form. Here it is called as, it is Ampere's law. Ampere's law in integral form, this is called as Ampere's law in point form. Okay, this is the total flux. What is this? What is the meaning of the first integral? Closed integral d dot ds is equals to q is nothing but the net outflow, the net flux coming out of any closed surface is equal to the total charge enclosed in the volume. Okay, then the divergence of the electric flux density is equal to the volume charge density. Here the circulation of the magnetic field in any closed length, the circulation of the magnetic field in any closed length is equal to the current crossing the surface. Okay, here the strength of the magnetic field intensity is called as the current density. Okay, so these are the very, very important results. Now come to the divergence and Stokes theorems. So what is the divergence theorem? Gauss divergence theorem. So by using this, we will define the divergence and Stokes theorem according to the mathematics only. It is like mathematics only, but we will include the electric and magnetic flux terms here. Okay, so suppose already we have observed that the closed integral d dot ds is equals to q. D dot ds is equals to q. But if I want to relate this integral with respect to the volume charge density, suppose we know what is volume charge density, rho v is equals to dq by dv. Okay, so from this what is q? I can write the q as integral rho v dv. Integral rho v dv. So what is rho v? Volume charge density into volume. Volume charge density coulomb per meter cube into meter cube will give the coulombs, the charge only. So I can write again what is rho v? Rho v is equals to del dot d, because rho v is equals to del dot d. Okay, del dot d dv. Understand? This is the surface integral. Which surface integral? Closed surface integral is converted into the volume integral, right? Is converted into the volume integral. Okay, so by using these two, we can write that what? Closed surface integral d dot ds is equals to what? Volume integral of del dot d dv. Del dot d dv. So that means this is what? Surface integral is converted into the volume integral. So this is called as the divergence theorem. Also called as, this is the Gauss divergence theorem. So what's happening here? The double integral is converted into volume integral means what? Double integral means what? Surface integral. Okay, I can also write this one as the closed surface integral d dot ds is equals to volume integral can be written as a triple integral del dot d dv. Okay, I can also write the above equation like this. So this is called as the Gauss theorem. Okay, So that means what? The double integral is converted into the triple integral. Okay, or otherwise, what is this? It is the closed surface. What's happening? Is converted into volume. Okay, so we can say that the closed surface can form the volume, right? So from the above thing, what we can write? The closed surface can form volume. The closed surface can form volume. So what is the divergence theorem? The divergence theorem relates the closed surface integral to the volume integral. Okay. Similarly, now come to the Stokes theorem. What is the Stokes theorem? If you come to the Stokes theorem, it is completed, right? Next, come to the Stokes theorem. What is this Stokes theorem means? So take this integral, the closed line integral. Okay, the closed line integral of h dot dl is equals to I. H dot dl is equals to I. What is this I? I'm relating this I, okay, by using this current density. What is J? J can be written as what? Di by ds. Right? Okay, from this what can I write? I as integral j dot ds. I can write I as integral j dot ds. Here I am writing the open surface. Okay, open surface integral. So it is very, very important. It is open surface integral j dot ds. Okay. So from this, what is j here? The j can be written as del cross h dot ds. Del cross h ds. So from these two, we can write directly. What we can write? The closed line integral of h dot dl can be written as the closed line integral of h dot dl can be written as what? The surface integral of del cross h ds dot ds. Okay. So this is called as the Stokes theorem. It is the Stokes theorem. In other words, we can also write this one as double integral to single integral. See, observe this. The closed line integral at a single integral is converted into double integral del cross h dot ds. Surface integral means double integral. Remember that. Line integral means it is a single integral. Okay. Double integral means surface integral means it is a double integral. Volume integral means it is a triple integral. Okay. So now the closed line integral is converted into an open surface integral. Okay. So from this, what we can say? It is the relation between the closed line integral to the open surface integral, or it is the relation between the closed line integral to the double integral. Okay, it is line integral to the surface integral or the single integral to the double integral. Okay, it is called as so what's happening here? It is a closed line forms open surface. Previously, what we got? A closed surface is forming the volume. Suppose if you close this, let us suppose this is an open surface. If I close this surface, in all the edges, what I will get? I'm getting a volume. Okay. Suppose if you take any line, if I close this line, what I am getting? An open surface. Okay. So that is the thing. So it is relating the Gauss theorem is relating. It is the relation between the closed surface integral to the volume integral, and the Stokes theorem is the relation between the closed line integral to the open surface integral. Okay, so you should remember, if you remember this statement, automatically what is this? The closed line forms open surface. Okay, it is the closed surface forms volume. Okay, if you know these two things, it is related to the Gauss theorem, it is related to the Stokes theorem. Okay, the closed line integral of h dot dl becoming open surface integral. There will not be any open surface integral. There will not be any closed there. Okay, it will be open. If you take the closed surface integral, you are getting the triple integral, that is volume integral. So it is related to Stokes theorem. It is divergence theorem. Okay, now the next completed. The next topic here is the Maxwell's equations. Static electromagnetic fields. The Maxwell's equations for the static electromagnetic fields, and this is very important concept here. Okay, it is the generally it is the heart of this subject. Okay, so what the Maxwell's has done, that is he collected all the equations from the Gauss and also the amperes, and he put it on the paper and he gives his own explanation. Okay, that see, if you observe what I said, he collected all the equations from the Gauss and the amperes. So what are the Gauss theorem? What is the Gauss theorem? Gauss law. The Gauss law states that first equation is Gauss law states that closed integral d dot ds is equals to q. Okay, so this is in integral form. Okay, the same Gauss law is said as in point form as the point form as the first equation is what? Del dot d is equals to rho v. Okay, this is the first equation. Already we know one more equation, that is Ampere's law. What is that Ampere's law? The Ampere's law is saying that what? Closed line integral h dot dl is equals to I. I am writing this one as the fourth equation. Okay, so what is the point form of this Ampere's law? The point form of this Ampere's law as del cross h is equals to j. We know these equations already. Okay, we proved these equations, how we got these equations. Okay, now what about the second and third equations? What about the second and third equation? The second equation is closed line integral of E dot dl is equals to something. Okay, what is the third equation? Closed surface integral of B dot ds is equals to something. Okay, okay, now something del cross E equals to something, then this is equals to del dot B is equals to something. So we have to, already we proved these four. Okay, we have to know these equations. Okay, just it is a conversion of Stokes theorem, and he used the Stokes theorem and the Gauss divergence theorem only. Okay, if you observe this, what is this closed integral E dot dl? What is E? E is nothing but what? Electric field intensity. So what is this electric field intensity? The closed line integral of E dot dl, it represents the work done in moving the charge. It is representing what? The work done in moving the charge. Okay, so why it is work done in moving the charge means, see, observe this. Observe this, it is electric field intensity. What are the units? Volts per meter. Okay, it is meter. The meter will get cancelled. The closed line integral of what we are getting finally? We are getting the volts here. We are getting the volts. So within the closed loop, what is the voltage? Within the closed loop, the voltage is 0 from where? It is 0 from where? From the KVL. Okay, Kirchhoff's voltage law. The algebraic sum of the voltages within the closed loop is equals to 0. So that means what? What is this E dot dl? Already we know any vector f dot dl, closed line integral f dot dl is called as the work done. Okay, the work done. Okay, the work done in the closed loop is 0. Okay, suppose what is the work done means? Suppose if you started from point A, okay, if you reach at point B, then in any of the ways, it can be said that you have done some work. Okay, suppose if you started from A and going and coming to the A and you are reaching to A means the work done is 0. It is similar to if you rotate around this, the closed loop, then what happens? If you travel around this closed loop, what happens? The work done is 0. And it can also be written as, it is the KVL. What is this KVL? This is called as the KVL. Okay, Kirchhoff's voltage law. Understand? Now, what about this? Suppose if I apply the Stokes theorem to this. Suppose if I apply the Stokes theorem to above integral, what is the Stokes theorem? Closed integral E dot dl is equals to 0. Suppose if I apply the Stokes theorem, I can convert this closed line integral into open surface integral. I can write this open surface integral as del cross E by adding one del cross to this. Okay, dot ds. I can write like this. It is ds. Okay, so from this is equals to 0 and this is also equals to 0. The surface cannot be 0 here, so we can write that this del cross E can be 0. So from this, what is del cross E? Del cross E is called as 0. Okay, so what is this del cross E represents? So what is this del cross E represents? The curl of E field is 0. The curl of E field is 0 means the curling nature, the rotating nature of the electric field is 0. So that's why it is called as irrotational. What is irrotational? The electric field is irrotational. Why it is irrotational? Why it is irrotational means we know. Suppose if you take a point charge here Q, okay, the electric flux lines will be like this. The electric flux lines will be like this, right? It is radially outward from this. These are the electric flux lines. We know that the electric flux lines are what? The straight lines. The straight line can never form the circle. The straight line go like this, it go like this, it go like this, go like this. It cannot form the circle. So this is what irrotational means. What? A straight line. Electric flux lines are straight lines. So E flux lines can never form circles. So this is the meaning of this one. Okay. Now, so what is the meaning of this del cross E? Again is mathematically, see if you observe this, del cross E is 0. Del cross E is 0 means what? It is del cross E, right? Del cross E is 0. What is del here? The del is the variation of any quantity in the direction of space, right? The variation of any quantity in the direction of space. But what is this actually? It is a del cross. The resultant will be something. Okay, suppose if you take A cross, okay, del cross E. Okay, what is this del cross E? The resultant will be, see, the del cross E, what is the meaning of this one? You will get the perpendicular result for this. Suppose if you multiply A cross B here, you will get C, and this C will be perpendicular to A and B, right? Perpendicular to A and B. The result will be perpendicular to A and perpendicular to B. That means, what is the resultant of this E? Okay, the orthogonal variation. What is this meaning? What is this meaning? It is 0 means what? Del cross E is 0 means what? The orthogonal variation electric field is, the orthogonal variation of the electric field is 0. The orthogonal variation of the electric field in the space is 0. That means if you go around this orthogonal, this is this one, right? Orthogonal variation means this one, in this direction. So what happening? So here, if you move around this line, if you move around perpendicular to, that means if you move perpendicular to the electric field lines, if you move perpendicular to the electric field lines means this one. If you move perpendicular to the electric field lines, if you move perpendicular to the electric field lines, so whatever the strength is here, you will also get the strength here X. You will also get the strength here X. Already we observed this. The strength here X. Here the strength here X. Here the strength here X. Okay. The perpendicular variation of the electric field in the space is 0. X minus X is 0. Okay. The orthogonal variation of the electric field in the direction of space is 0. So that's why, that means what? What does that mean? This is saying that the field is, it is nothing but, this field is also can be called as, it is the conservative field. Conservative field. Okay, it is also called as the conservative field. Okay, so this is the meaning of this one. So del cross E is equals to 0. What is del cross E means? The perpendicular variation of the electric field. Okay, if you move along the, if you move orthogonal to this, perpendicular to this, the variation from one point to another point is 0. Okay, now what about the third Maxwell's equation? What is the third Maxwell's equation? What is the third Maxwell's equation? The third Maxwell's equation is, observe this, closed surface integral of B dot ds. What is B? B is magnetic flux density. The magnetic flux densities are, units of the magnetic flux density are Weber per meter square into meter square. These two will get cancelled. These are only the Webers. Okay. So within the closed loop, okay, the magnetic flux is what? Already we know that. What is the magnetic flux? The magnetic field lines are the circles. Okay. Suppose if you take any closed surface like this, if you take any closed surface, already we know, suppose the magnetic field is entering this, let us suppose the magnetic field is entering like this. What happens? Because these are the closed lines, because the magnetic field lines are the closed lines, what happens? Understand? So whatever the field is entering is also leaving. Okay, you take any closed surface. Okay, whatever the magnetic flux, okay, magnetic flux is entering this closed surface is also leaving, okay. So that means what is the net magnetic flux within the closed surface? The entering flux is equal to the leaving flux. Entering flux is equals to the leaving flux. So entering flux is equals to the leaving flux means what? What is the net flux? So the net flux is equals to 0. The net flux within the closed surface is equals to the 0. Okay, one is positive and one is negative. So that's why the magnetic flux, what is B dot ds? B dot ds represents the magnetic flux. Okay, within the closed surface is 0. Okay, it is called as 0. Then what about this del dot B? Then what about this del dot B? Already we know that. So if you use the Gauss divergence theorem here, B dot ds is equals to 0, closed integral, B dot ds is equals to 0, and this will be equals to, I can use the Gauss divergence theorem here, the closed line, the closed surface integral is converted into the closed surface integral is converted into the volume integral by including del dot B. Okay, by including del dot B. So this is the conversion of, this is the Gauss divergence theorem. Okay, so from this what we can write? So del dot B can be 0 because volume cannot be 0. Okay, del dot B is equals to 0. So what is this del dot B? The divergence of the magnetic field is 0. The divergence of the magnetic field is 0. That means, observe this, how the magnetic field will be? There will not be any divergence for the magnetic field. Why? Because always the magnetic flux lines are the curls, the circles. These are the H field. The magnetic field lines are the circles. It cannot form the divergence. So these circles can never form the circles can never form the straight lines. So these are circles, right? So it is del dot B is a non-zero value, means there is existing some divergence. But here see, del dot B is 0 means the divergence of this magnetic field is 0. The outward nature of the magnetic field is 0. Understand? The outward nature of the magnetic field is 0. So that's why always the magnetic field lines are circles, right? Write a note. What is the note? That note is what? H field lines. Can never form straight lines. Can never form the straight lines. Okay. So these are the Maxwell's equation, and it is also showing that what is del dot B? Del dot B means what? What is this nature? This nature is nothing but what? This nature is nothing but a solenoid nature. How the solenoid will be? The solenoid will be like this. Okay. The solenoid will be like this. So for this kind of fields, see, if you observe these kind of fields, so these are circles. For these kind of circles, can we say where the starting and ending point? We cannot say for the circle the starting and ending point for the circle. Okay, so that's why we can say that the circle will not be having any source and the circle will not be having any sink. So what is the solenoid nature means? What? Okay, the magnetic field lines, no source and sink for magnetic field lines. Okay, so what is the solenoid nature means? There is no source and sink for the magnetic field lines. So these are the four, actually these are 8 equations here. Okay, one are integral forms and one is point form, and these are very very important for the subject, and these all things will be used in the entire subject. So you should remember all these equations, and you have to know the importance of the and the significance, the physical significance of these Maxwell's equations. Okay, so like this. So these are called as the Maxwell's equations for the static electromagnetic fields. And if you go for the time varying fields, it differs. Okay, if you go for the time varying fields, it differs. So by observing this, what is this? It is the Gauss law. What is this? This is a Gauss law. What about this? This is Ampere's law. These two are the Ampere's law. This is saying that it is the KVL. This is called as the irrotational. The electric field lines are irrotational, or it is also called as the conservative. These are the solenoid. So it is saying that no monopoles exist. It is saying that there are no monopoles exist for the magnets. Okay, so that is what entering flux is equal to the leaving flux. Okay, so this is what about the Maxwell's equations. So from this, can we write from the above equations? See, it is del cross E is equals to 0. So can I write del cross D is equals to 0 here? Can we write del cross D is equals to 0? So this is an important question for the public sector unit examination. Del cross D is equals to 0. Can we write? So observe this. What is the D? D is equals to epsilon E. D is equals to epsilon E. So del cross epsilon E. Del cross epsilon E. It will be 0 if what? And this is coming out. Okay, if I write here means it will be 0, because epsilon into del cross E is 0. If where epsilon is constant. What is epsilon is constant? Epsilon is constant means it is homogeneous medium. If you take the homogeneous medium, you can write what? Del cross D is equals to 0. Otherwise, you cannot write, because if this is varying, if sigma is not a constant, if the sigma is not a constant means what? If sigma is varying in the space, so you cannot write the derivative of this variable outside. Okay, so that's why. So this is wrong if it is not a constant. Okay, and it is equals to 0 if what? Sigma is constant. Similarly, can we write del cross H is equals to, sorry, this is del dot B equals to 0, right? Del dot H is equals to 0. Can we write? You can write if what? What is B? H is equals to B by mu here. You can write H is equals to B by mu. Okay, so del dot B by mu is equals to 0 if you consider this mu as a constant. That means if mu is equals to constant, you can take this mu outside, you can write del dot B is 0. Okay, if this is varying with respect to distance, if this mu is varying in the space, it is not a constant. You cannot take this one as outside. Okay, so that's why you cannot write. So that means if it is constant means what? It is homogeneous medium. You can write del dot H is equals to 0, and these are the two important relations for the homogeneous medium. Okay.